When you decide to learn about artificial intelligence, you usually hit a wall immediately. You are met with complex calculus, dense programming code, and heavy server architectures. Most tutorials hand you a pile of code and expect you to build a neural network. They start at step 10, long before you have taken step 1. If we want to understand machine learning, we need to strip away the machine entirely. Let's start with a much simpler question. What does it actually mean for anything to learn? Think about how you learned to ride a bike or cook a meal. You tried something, noticed what went wrong, adjusted your balance or the heat, and tried again. Once you see this basic loop in your own life, the algorithms stop being frightening. They are simply mathematical tools built to copy that exact same human process. We often assume that feeding a computer data is like giving it pure objective reality. Let's look at this diagram. The world is a vast landscape. The data is just a tiny window frame. It is a selective memory. It tells you something happened, but it doesn't capture everything, and it rarely tells you why. If a system trains on a window that shifts its focus to only one corner of the world, it learns a distorted rule. We end up trusting a system that hasn't actually seen the whole picture. Data is not knowledge, and it is certainly not wisdom. It is just recorded contact with the world, waiting to be organized into something useful. In school, we are conditioned to hide our mistakes. An error means a bad grade, a red mark on a test, or a personal failure. Here, in this diagram of a target, the arrow misses the center. In a learning system, that gap is not a reason for shame. It is a measurement. It tells you the exact distance and direction of the miss. We make a prediction, we measure the error, and we update our settings. The error morphs into feedback. When we stop treating a mistake as an insult, we can use it to guide our next attempt. Improvement becomes a steady, mechanical routine. A system can look incredibly smart if it perfectly recalls every past example it was shown. But memorization is a trap. The moment the system faces a scenario it hasn't memorized, it freezes. Notice the difference in this diagram. If the system only recognizes this specific wooden chair, that is memory. If it extracts the structural idea of a chair and uses that to identify a brand new plastic chair, that is generalization. It is learning that travels. The world tomorrow will never be a perfect copy of the world yesterday. A model proves its worth when its learning survives outside the practice room. You take in data, you make a prediction, you measure the error, you update your approach, you generalize to the next problem. That is how intelligence is built. All the complex mathematics and code you see in advanced computer science are doing nothing more than measuring those exact steps. This brings us to the book Deep Learning from First Principles. As you can see, it is designed to build out these core ideas before you ever look at a line of code. It does not promise a shortcut or a weekend boot camp. It gives you room to breathe, process, and build a strong foundation at a measured pace. By understanding the working parts before the heavy machinery takes over, the fear disappears. You are left with the calm, capable judgment required to navigate the modern world.